Hello students, in this video we are going to discuss objective questions from practical number 3. So first question is, a P-P-1 graph is tree if G is connected, G is acyclic, both A and B are correct, none of the above. Okay. So we know that a graph G P comma Q is tree if and only if G is connected and acyclic. Here we have given a graph G on P vertices and P-1 edges. So it should be connected and acyclic to be a tree. So third option, that is option C, both A and B correct, should be true. You can apply the theorem, tree equivalent statement theorem. G is connected and Q is equal to P-1. These three statements are equivalent. G is acyclic and Q is equal to P-1, and third is G is tree. So G is connected and Q is equal to P-1, then G is tree. First implies third, second implies third. Similarly, third implies second, third implies first. So here if G is a graph on P vertices and P-1 edges, then it is tree if G is connected and G is acyclic. So option C, that is both A and B are correct, is true. Second is a spanning tree of a simple graph on 24 of order 24 has. So what is order? Order of any graph is nothing but number of vertices in graph. Number of vertices in graph. Just we have discussed these three statements are equivalent. G is connected and Q is equal to P-1. G is acyclic and Q is equal to P-1. And G is tree. So if G is tree on P vertices and Q edges, then Q is equal to P-1. If G PQ is a tree, then Q is equal to P-1. Here we have given order 24. That means number of edges is equal to 24. So from this theorem, Q is equal to 24 minus 1, that is 23. So 23 given in option B. So option B is correct. Third is, the number of spanning trees of graph on n vertices is. We can apply Calais formula or Calais theorem for this. What is Calais theorem? A complete graph Kn has n raised to n minus 2 spanning trees. So here we have given a graph on n vertices. So number of spanning trees on n vertices is n raised to n minus 2. That is, first option is correct. Spanning tree of a graph G on P vertices is. So what is spanning tree? What is actually spanning tree? Spanning tree of graph G is spanning subgraph of G, which is tree. Spanning subgraph of G, which is tree. So subgraph of G, this option is correct. But subgraph of G, here it is not all possibilities are covered in subgraph of G. Connected acyclic subgraph of G on P vertices. This is correct because spanning subgraph is a spanning tree is a spanning subgraph which is tree. That means spanning subgraph which is tree means connected and acyclic. These all conditions are covered in option B. So option B is correct option. Fifth MCQ is, If GPQ is a graph where Q is equal to P minus 1, then G is tree, G is connected, and G is acyclic, and all of these. Okay, so GPQ is a graph where Q is equal to P minus 1. So consider a graph. This graph is 4, 3. This graph contains cycle. So G is acyclic. This option is incorrect. G is connected. This option is also incorrect. G is tree. This option is also incorrect. All of the above. This option is also incorrect. So all the options are incorrect. So you can write here option D, none of these. This graph is counter example for all of these. G is tree, G is connected, and G is acyclic. So option D, none of these is correct option. 6. If G is a tree on P vertices and Q edges, then Q is equal to. Already, while discussing first MCQ, we have discussed that if GPQ is a tree, then Q is equal to P minus 1. So option B is correct option. Next is number of non-isomorphic trees on 5 vertices is. So now I am drawing. The answer is 3. I am drawing these 3 trees on 5 vertices which are non-isomorphic. This is T1. This is T2. 1, 2, 3, 4, 5. This is T3. So here there are 2 pendant vertices. In T2, there are T2 and T3. In T2 and T3, there are 3 pendant vertices. From this property, we can say T1 not isomorphic to T2 and T1 not isomorphic to T3. Now to check why T2 and T3 are not isomorphic. If you observe, T2 is a binary tree and T3 is a complete binary tree. So T2 and T3 are not isomorphic as T2 is a simple binary tree and T3 is a complete binary tree. So option second, that is 3, is correct option. Next is a spanning tree of graph G has. So what is definition of spanning tree? A spanning tree is nothing but spanning subgraph. But what is spanning subgraph? A spanning subgraph H of G, graph G, is a graph where vertex set of H is equal to vertex set of G and vertex edge set of H is subset of edge set of G. This is definition of spanning subgraph of graph G. And here we have asked about spanning tree of graph G. So spanning subgraph of graph G, which is tree, is called as spanning tree. So this will satisfy vertex set of T is equal to vertex set of G and edge set of T subset of edge set of G. This is given in option first. So option A is correct option. 9th MCQ is if there is a tree with 3 vertices of degree 2. So I am writing here 3 vertices of degree 2, 4 vertices of degree 3 and 3 vertices of degree 4. Then the number of pendant vertices. So let P is number of pendant vertices or L. We will consider L represents vertices with degree 1. Number of vertices with degree 1. So what we know, if GPQ is a tree, then Q is equal to P minus 1 and by handshaking lemma, summation degree of Vi is equal to 2 into number of edges. So I am writing here 2 into Q is P minus 1. But what is number of vertices here? If there is a tree with number of pendant vertices E. If there is a tree with 3 vertices of degree 2, 4 vertices of degree 3 and 3 vertices of degree 4. Okay. So let us find what is number of pendant vertices. So if there are total P vertices, then L is equal to P is equal to 3 vertices of degree 4. So 3 plus 4 plus 3 plus L is equal to P. That is 3 plus 3, 6 plus 4, 10 plus L. So P is equal to 10 plus L. So I am writing here 2 into 10 plus L minus 1. That is nothing but 10 plus 1, 10 minus 1, 9. 9 into 2, 18. 18 plus 2L. And what is sum of degrees of all vertices? There are 3 vertices of degree 2 plus 4 vertices of degree 3 plus 3 vertices of degree 4 plus L vertices of degree 1. That is nothing but 3 2s are 6 plus 4 3s are 12 plus 3 4s are 12 plus L is equal to 18 plus 12. 6 plus 12, 18. 18, 18 will get cancelled. 12 plus L is equal to 2L. So 12 is equal to 2L minus L. That is L is equal to 12. So option A is correct option. A is equal to 12. Next, T is a tree with n vertices, n greater than or equal to 4, and V be the vertex of maximum degree in T. Then T is a path if degree of V is. Okay. V is a vertex in vertex of maximum degree. So I am drawing a path on 4 vertices because we have given. So I have drawn a graph on 5 vertices. We have given n greater than or equal to 4. So I am drawing a tree which is path on 4 and 5 vertices. So here degrees of vertices are 1, 2, 2, 1. Here degrees of vertices are 1, 2, 2, 2, 1. So if you draw a tree which is a path, then every vertex there will be 2 pendant vertices and all other remaining vertices, all other remaining n minus 2 vertices will have degree 2. So we have given V is a vertex of maximum degree in T. So what is maximum of 1 and 2? That is 2. And 2 is given in option B. So option B is a correct option. Next is the number of different pairwise non-isomorphic trees of order 4 are. Similar to non-isomorphic pairwise non-isomorphic tree on 5 vertices, we are drawing non-isomorphic trees on 4 vertices. So first is T1 and second. So there are only 2 trees on 4 vertices which are non-isomorphic. So option B is correct option. Now let us check why these 2 are not isomorphic. Because T1 has 3 pendant vertices and T2 has only 2 pendant vertices. Why T2 has only 2 pendant vertices? That's why these T1 and T2 are not isomorphic trees. Next is the number of spanning trees of complete graph K8 is. So these options are the number of spanning trees of complete graph K8. Actually this is 4 raised to 8, 6 raised to 8 and 8 raised to 6. We can easily find answer of this by using Calais formula. What is Calais formula? For a complete graph Kn, number of spanning trees is equal to n raised to n minus 2. Here we have given K8. That means n is equal to 8. So n raised to n minus 2 is nothing but 8 raised to 8 minus 2, which is 8 raised to 6. 8 raised to 6 is given in option C. So option C is correct option. 13th MCQ is the number of non-cut vertices of a connected PQ graph with P greater than or equal to 3 is. We have given connected PQ graph and they have asked the number of non-cut vertices. We have already discussed a theorem. Every non-trivial graph has at least two non-cut vertices. By using this theorem, option C, at least 2 is a correct option. 14th is, let T is a tree on n greater than or equal to 3 vertices, then the number of cut vertices of tree is. So I am drawing here a tree on 3 vertices. This is first tree, T1. It has cut vertices. It has one cut vertex. If I draw this tree, then this V1 and V2 are cut vertices of this T2. So 0 is incorrect option. At least 2 is incorrect option because T1 has only one cut vertex. So at least 2 is also incorrect option. N is incorrect because T1 has 3 vertices and 3 non-cut vertices. Number of cut vertices is not 3. So option B is correct option. At least 1. Let T. 15th MCQ is, let T is a tree on 3 n greater than or equal to 3 vertices. If V is a cut vertex of T, then degree of V is. We have discussed this, or you have first question in your descriptive question of practical number 3, that is, show that if T is a tree, then and V is a cut vertex of T, then degree of V greater than 1. Or you can say, if degree of V is equal to 1, then V will be pendant vertex, and pendant vertex cannot be a cut vertex. So greater than 1 is a correct option. T is a tree, V is a cut vertex, then degree of V is greater than T. Cut vertex of tree does not exist. This is not true. We can easily see that tree has cut vertex. The number of cut vertices of tree on n greater than or equal to 3 vertices, which is a path, is. Okay. So we want to calculate number of cut vertices. I am drawing here a tree on 3 vertices. I am calling this as T on 3 vertices, so T3. Next is T4. And on 5 vertices, 3, 4, 5. T5. In general, on P vertices, TP. TP. So here this is cut vertex, say V1. Here this vertex V1 and this vertex V2 are 2 cut vertices. Here V1, V2 and V3 are cut vertices. So if you draw a tree which is a path, then there are 2 pendant vertices in that path, and all other remaining vertices will be cut vertices of graph Z. If there are total n vertices, then the extreme vertices on the extreme are pendant vertices which are not cut vertices. So you can subtract those 2 from n and you will have n minus 2, remaining n minus 2 vertices as a cut vertices. Or you can see in T3 there is 1 cut vertex, that is 3 minus 1. In T4 there are 2 cut vertices, so 4 minus 2 is 2. In T5 there are 3 cut vertices, that is 5 minus 2. So in general there are n minus 2 cut vertices if T is a path. If T is a tree which is a path. 17th is the number of vertices required to disconnect a tree on at least 3 vertices is. So this is one. You can easily see a tree is a graph on p vertices and p minus 1 edges. It is minimally disconnected graph. What is minimally disconnected graph? A graph whose one vertex is removed, then graph becomes disconnected. Then it is called as minimally disconnected graph. So option A is correct option. Next is, which of the following statement is false? A graph has cut vertex, then it contains cut edge. So I am drawing a graph here. So this graph is a example where it has cut vertex V but it has no cut edge. So first option is incorrect. We want to find incorrect option. So first option is correct because we want incorrect option. First statement. B, if a graph contains cut edge, then it contains cut vertex. This is a standard result and already we have discussed this theorem in our classroom. If a graph with at least 3 vertices contains cut edge, then it contains cut vertex. This is similar to statement B, but in statement B, they have not given number of vertices. Instead of this, in C, they have given number of vertices in graph. See, there exists a graph with cut edge having no cut vertex. So yes, if you draw K2, it has cut edge E1. If I remove E1, then graph will be disconnected. But if I remove U or V, then graph is not disconnected. That means K2 has cut edge, but it has no cut vertex. So we have proved the existence of a graph with which has cut edge, but it has no cut vertex. So these three options are correct statement, and we wanted to find incorrect or false statement. So option A is correct option. Every non-trivial loopless graph has at least 2 non-cut vertices. This is standard result. We have discussed this earlier. If G is a tree, then each edge of G is cut edge. And what is cut edge? Cut edge is nothing but breach. You can see if I draw this tree, you may remove any edge and can find after removal of every edge, graph is becoming disconnected graph. So every edge of tree is a cut edge, and cut edge is nothing but breach. So we have given the degree sequence of graph G, that is 1, 2, 2, 3, 4, 4. The size of spanning tree is, okay. What is size? Size is nothing but number of edges. Number of edges in graph G. The number of edges is always number of vertices minus 1. So what is number of vertices? This is degree sequence. That means each term in this sequence representing degree of vertex. So how many vertices will be there? 1, 2, 3, 4, 5, 6. That is number of term in this sequence is nothing but number of vertices in graph G, which are 6. So Q is equal to 6 minus 1, that is 5. 5 is given in option B. So option B is correct option. Next is, from a simple graph G of order 10 and size 42. Order 10 means number of vertices 10 and size means number of edges 42. G dot E is constructed by contraction of G. Then order and size of G dot E. Already we have discussed this in our lecture that if G dot E is a graph obtained from graph G by contracting an edge E, then vertex set of G dot E, cardinality of vertex set of G dot E is equal to cardinality of vertex set of G minus 1, and cardinality of edge set of G dot E is equal to cardinality of edge set of G minus 1. So here cardinality of vertex set of G dot E is equal to 10 minus 1, that is 9, and cardinality of edge set of G is 42 minus 1, that is 41. So 9 and 41 is correct option. Option B is correct. 9 and 41. The number of different label trees of order 15 is. So what is number of different label trees? Again, you can apply Calais formula and find number of trees of order 15, that is number of spanning trees of K15, that is tau of Kn is equal to n raised to n minus 2. So tau of K15 is equal to 15 raised to 15 minus 2, that is 15 raised to 13. Last MCQ is, consider the Proofer sequence 10 10 10 3 9 8 7 1 2 3 1 10 for the label tree T. Then degree in T of the vertex with label 8 is. Okay. For that we have to draw tree using Proofer code algorithm. We have discussed and solved problems on this. So let us solve this. We are given Proofer code as 10 10 10 3 9 8 7 2 3 1 10. So this is Proofer code. We know that if tree is on n vertices, then Proofer code has n minus 2 terms. Here number of terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just a minute. 10, 10, 10, 3, 9, 8, 7, 1, 2. Okay, 7, 1, 2, 3, 1, 10. So number of terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means the tree will have 12 plus 2 is equal to 14 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So labels. What is label? Labels. I am writing all the numbers from 1 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now remove the numbers from labels which are present in Proofer code. So 1 is present in Proofer code, 2 is present, 3 is present, 4 is not present, 5 is not present, 6 not present, 7 is present, 8 is present, 9 present, 10 present, 11 not present, 12 not present, 13, 14 not present. So what is minimum label? Minimum label is 4 and first term is 10. So we are drawing an edge between 4 and 10. Next is what is remaining Proofer code? 10. This 10 is, we are not considering this 10 because we have drawn an edge between 4 and this vertex 10. Now I am writing from this 10, 10, 3, 9, 8, 7, 1, 2, 3, 1, 10. So labels. Again I am writing labels from 1 to 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Delete the labels which are already present in Proofer code. So 1 is present, 2 is present, 3 is present, 4 is, we are not considering 4 because already 4 is used in first step. 5 is not present, 6 is not present, 7 present, 8 not present, 9 present, 10 present, 11, 12, 13, 14. Now draw an edge between 5 and this 10. So I have drawn an edge between 5 and 10, but first draw that first edge, that is 4, 10, and next is 5, 10. Now remaining labels are, this 10 is also cancelled. Proofer code is 10, 3, 9, 8, 7, 1, 2, 3, 1, 10. And labels are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1 is present, so I have cancelled 1. 2 is present, 3 is present, 4 is already taken, 5 is already taken, 6 is not present, 7 is present, 8 is present, 9 present, 10 present, 11, 12, 13, 14. Now draw an edge between 6 and 10. 4, 10, 5 and 6. Again, the proofer code is, now delete this 10 and the remaining proofer code is 3, 9, 8, 7, 1, 2, 3, 1, 10 and labels. Now I am writing labels. So 1 is present in this, so I am not writing 1. 2 is present, so I am not writing 2. 3 is present, I am not writing 3. 4 is already taken, 5 is already taken, 6 is already taken. 7 is present, so I am not writing 7. 8 is already present, I am not writing 8. Similarly, 9 and 10. So labels are 11, 12, 13 and 14. Now join an edge between 3 and 11. 4, 10, 6, 5, 3, 11. Now what is proofer code? 3 is cancelled. So 9, 8, 7, 1, 2, 3, 1, 10. And what are labels? So labels 1, 2, 3. 1 is present, so I am not taking 1. 2 is present, 3 is present. 4 is not present, but 4 is already taken. 5 is not present, but 5 is also already taken. Similarly, 6 is already taken. 7 present, 7, 8, 9, no. 10 is present, so I am not taking 10. 11 is already taken, so now 12, 13, 14. Now draw an edge between 9 and 12. 4, 10, 5, 6, 3, 11, 9 and 10. 9 and 12. Okay, sorry, 9 and 12. 9, 12. Again, the remaining proofer code is 8, 7, 1, 2, 3, 1, 10. And labels are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 is present, I am cancelling 1, 2 is present, 3 is present, 4 is already taken, 5 is already taken, 6 is already taken, 7 is present, so I am not taking 7, 8 is present, 9 is not present, so I am 9 is not, I'm not cancelling 9 because 9 is not present in this sequence. 10 is present, so I'm cancelling 10, 11, 12, 13, 14. 11 is not present, but 11 is already used, so I'm cancelling 11. Here we have used label 11. Similarly, we have used label 12, so I'm cancelling 12 also, 13, 14. Now draw an edge between 8 and 9. So graph will be 4, 10, 5, 6, 3, 11, 8, 9, 12. Now what is proofer code? This 8 is taken. So proofer code is 7, 1. Proofer code 7, 1, 2, 3, 1, 10. And labels are, again I am writing from 1 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1 is present, I am cancelling 1, 2 is present, 3 is present, 10 is present and 7 is present. Which labels are taken from step 1? At step 1, we have taken 4. At step 2, 5, 4, 5, 6, 11, 12, 6, 5, as 4, 5, 6, 11, 12. So we have already taken 4, 5, 6, 9, 4, 5, 6, 11, 12, and at this step we have taken 9. So I am not considering 9 here because already 9 is taken. So what are remaining labels? 8, 13, 14, out of which minimum is 8. So I am drawing age between 7 and 8. 4, 10, 5, 6. 4, 10, 5, 6, 3, 11, 8, 9, 12, and now age between 7 and 8. 7 and 8. We want to find degree of a vertex with label 8. So there are possibilities 1, 2, 3, 4. So we already have degree 2. So one option is incorrect option. Now let us solve further. So at this step, 7 from proofer code is cancelled and 8 from label is cancelled. Now the proofer code is updated. Proofer code is 1, 2, 3, 1, 10, and labels 1 is present in proofer code, so I am not considering 1, 2, 3. 4 is already covered, 5 is already covered, 7 is already covered, 6 is already covered, 7 is not covered. So I am considering 7. 8 is covered, 9 is covered, 10 is not covered, 11, 12 is covered, 13 and 14. But you can see already 8 is not present in label. So there will not be any age which is adjacent to 8. So we can say degree of vertex with label 8 is 2. You may solve the entire problem, but at last you will get degree of 8 is 2. So I am not solving entire problem and drawing the final tree because I have got answer as 2. Degree of vertex with label 8 is 2. So option B is a correct option. In this video, we have discussed all MCQs from practical number 2. If you have any doubt, then you can ask, you can comment. Thank you.